Hi, here's a question to find the most general antiderivative of the function. So that is basically finding the indefinite integral. Means to find the antiderivative the most general. So that means to find indefinite integral. So then we basically set up the indefinite integral notation to solve this question. So to solve this, let's call this antiderivative expression. Typically the textbook denotes it as capital F. So that would be indefinite integral, meaning just with no numbers in the bottom and top. Those are called integrand. And we basically put this function in here. So, and we are taking antiderivative with respect to variable x. That's why we put dx. That's change of x, because this denotes rate of change. That equals to indefinite integral. We're just writing this expression. Whenever you come across rational fraction, here we've got multiple functions, rational function with trigonometry and log function. So there's no reason to panic. Just take it one at a time. So this you can split because it's a lot easier to take antiderivative of that when you split it. So this can be written as two separate functions, basically x2 over x3 minus x over x3, and then write the rest as it is. Since there are multiple things, it's safe to put the whole bracket around it and then say dx. So we can simplify these things. You can cancel this and then the power will be just 1. And you can cancel this and the power will change to 2. So integral, and we've just got 1 over x minus 1 over x to the power of 2 minus sine x plus log 3 dx. So here when you look at these functions, you see that whenever you have 1 over x, that is ln function. So that's equal to, so now we are getting rid of this. So from this step to this step, we're getting rid of integral sign by taking the actual antiderivative. So this is ln x. The reason why we put these bars here is because x can be any number. We are saying that it's most general case. X can be anything. We're not imposing any restriction. But we know that for ln, x must be greater than 0 strictly because at 0 there is vertical asymptote and this all takes place to the right side of the Cartesian plane. So we know that log function looks like this, which is inverse of exponential. And so this line is the vertical asymptote, which is x is equal to 0 and everything is to the right. There's to be nothing to the left of it, which is where x is negative. Therefore, x must be always greater than 0. That's why we put absolute value, because for the other functions, x can be negative, but strictly for this, x to be positive, so we put absolute value for this to exist. And then this is 1 over x. So if we had 1 over x, that's basically equal to x to the power of negative 1. So if we're imagining taking derivative, negative will come out, which will change the sign. So we need to have this as positive, and then this will change to negative 2, which is this. And for sine, it was cosine, so write the cosine first. Antiderivative of cosine is negative sine, so the sign will change as well, so it's plus. So these signs are very important. You can lose partial marks for these. And for log, you can think of, oh, what am I going to do with this? But notice that this is just a constant number. So it's like c. And if there's a number, then you just add x to it. So this is plus log 3 times x, or you can switch them, make sure that you separate them so that it doesn't look like log bracket 3x. And because it says most general case, when it says most general case, you have to remember to put the constant factor, which is c. This is this big constant factor. This is what defines the antiderivative to be most general. So this is how you go about to find the most general antiderivative of the given function. That is exactly identical way of saying determine the indefinite integral. For definite integral, there are numbers. Indefinite, it doesn't have it. Therefore, you must remember to put the constant factor c.